I am going to start the Unit 7 Part 2 review. So number 1 is asking us to factor. And this problem has two terms, 1, 2. So first we look for a GCF, but there's no GCF. Then because there's two terms, we look to see if it's a difference of squares. It's got a minus sign. 1's a perfect square, but 27 is not a perfect square. Plus our exponent's not even, so that's out. Then we look to see if it's a difference of cubes or if it's a sum of cubes. And it's a minus, so it's a difference. We've got an exponent, that's a multiple of 3, and 27 and 1 are both perfect cubes. Now, if you're wondering, how do I know that? Well, if I try to take the cubed root of 27, I get a pretty little whole number. And if I try to take the cubed root of 1, I get another pretty little whole number. So they are perfect cubes. And the exponent has to be a multiple of 3. 3, 6, 9, 12, etc. Okay, so this has a funky looking formula. Now, if you're not one of my students, then I apologize because you will not have heard this, but I have a song for how I factor these. And it's to the tune of Mary Had a Little Lamb. The letters go A, B. Oh my God, I'm so sorry. That was my cat. She clearly did not like my song. Oh my gosh. You just made a horrible mess, kitty. Let me try that again. The letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. All right. So I know you guys that don't have me as a teacher have not done that before, but that's okay. All right. So first we need to figure out the A. So what times what times what makes 27x cubed? 3x. 3 times 3 times 3 is 27. X times x times x is x cubed. And then we need to figure out our b. What times what times what makes 1? Well, 1 times 1 times 1 makes 1. So the cubed root of this is 3x and the cubed root of this is 1. Okay, so now that I know who a and b are, I'm ready to factor. Little baby set of parentheses and big set of parentheses. So first it wants a, and a is 3x. Then it wants b, and b is 1. Then it wants me to take a and square it. So 3x times 3x, that's 9x squared. Then it wants a times b, so 3x times 1, that's 3x. And b squared, 1 times 1, well, that's 1. Okay, and then the signs go same, different, plus. So whatever this sign is, it's the same, different, plus. And I know those of you that have other teachers learned SOAP. Okay, and so which answer choice is this? It is answer choice A. So A is our winner, winner, chicken dinner. Okay, next one is asking us to write this in quadratic form. Well, quadratic form is when you have something with a squared and then you don't have anything else and then you have a constant. So we want something squared, then we want no exponent, and then we want a constant. Well, if I look over here to see who kind of follows that pattern, the only one that it is B. Now, not possible could possibly be an answer, but these are not squareds. These need to be squareds, so those are out. This has a squared, then it has nothing, then it has the constant. Now let's see if this means the same thing as this. So remember, whenever you have a power raised to a power, you multiply exponents, and 3 times 2 makes the 6 that we originally had. And then this is still 7 in cube, just like that. The minus 6 is still a minus 6. Okay. So B means the exact same thing that this does. Okay, number 3. So this one we are solving. So I'm going to factor it and I'm going to solve it. So this is in quadratic form, but it doesn't have the usual look. The exponents go 4, 2, constant. So whenever that happens, I just A times C rooftop it with a twist. So A times C, 1 times negative 24 is negative 24. We want the numbers to add to make 2. So two numbers that multiply to make negative 24, that add to make 2. 6 times negative 4 makes negative 24, and 6 plus negative 4 makes 2. Okay, because of the 1 in front, it's the easy one. So I get to put these numbers in the back. So that's a positive 6. That's a minus 4. And then instead of b and b in the front, because that would only make b squared, and I need b to the 4th, I need b squared and b squared. That way, when you multiply b squared and b squared, you get b to the 4th. Okay, so now I'm going to look to see if either of these is a difference of squares, because that's what happens when you get even exponents. You can create a difference of squares. And this guy is. He's got a minus, even exponent, and 4 is a perfect square. So every time there's a difference of squares, that factors with 2 sets of parentheses, one with a plus, one with a minus. And then you take the square roots. The square root of b squared is b, because b times b is b squared. The square root of 4 is 2, because 2 times 2 is 4. And then this guy is not a difference of squares, so he just comes down. Okay, so if all it wanted me to do was factor, that would be the factored answer, but it wants me to solve. And I know that for 2 reasons. 1, I see the word solve, and 2, I see the equals 0. Okay, so if there's an equals, then that means we want to solve. Okay, so let's start with the easy ones. If you set b minus 2 equal to 0, what would you get if you solved that? A positive 2, because you would add 2 to both sides. Okay, what if you set b plus 2 equal to 0? You'd get a negative 2, because you would subtract 2 from both sides. So there's 2 of the answers. I'm going to have 4 answers when I'm done, because this is b to the 4th. So now I'm going to take this factor, b squared plus 6, and set it equal to 0. So to get b by itself, I have to get rid of addition of 6, so I'm going to subtract it. The b squared comes down. 0 minus 6 is negative 6. And then to get rid of the squared, I square root. The minute I square root, I slap down my plus minus. And then who's going to take that negative out? I. And then you're left with a positive square root of 6. And you can't take the square root of 6, nor can you break it down. So these are my other 2 answers. So the plus is 1 answer, the minus is a second answer. So 1, 2, 3, 4. 4 total answers. Okay, and where do we see it? 2, negative 2. And it is C. So there's our 2 and our negative 2, and then we've got the negative I squared root of 6 and the positive I squared root of 6. Okay, number 4. Now, this is asking us to use synthetic division to find f of negative 3. I'm not going to do it that way, but if I did, I'd put negative 3 in the box, I'd do synthetic division, and the remainder would be my answer. What I'm going to do is I am going to just put negative 3 into every single x. So in my calculator, where that x is, I'll build parentheses. I'll put negative 3 in there. I'll raise it to the 4th. Minus 4. Where that x is, I'll build parentheses. I'll put negative 3 in there. Raise it to the 3rd. Plus 2. Where that x is, I'll build parentheses. Put negative 3 in there. Raise it to the 2nd. Minus 4. Where that x is, I build parentheses, put negative 3 in there, and in the very back, plus 6. Okay, and I'm just going to type that whole stretch into my calculator right now. Okay, so I've got parentheses, negative 3, close it, raise it to the 4th. Minus 4, parentheses, negative 3, close it, raise it to the 3rd. Plus 2, parentheses, negative 3, and square it. Minus 4, parentheses, put your negative 3 in there, plus 6. And we get 225. But you could have done this with synthetic division as well. I just don't see the need to do it with synthetic division, other than the fact that you've been working on synthetic division in the last 2 units of Unit 7. Okay, so that is f of negative 3. And if you had to type this answer in, you would just type in the 225. That's all you would answer in. Okay, the next one. It tells you one factor of this polynomial. It says that it's x plus 4, and it's asking you to find the remaining factors. Okay, I'm going to do this with synthetic division, and then I'm going to show you something else. All right, if x plus 4 is a factor, then I can do synthetic division and get a remainder of 0, and then factor my answer. So if x plus 4 is a factor, negative 4 is what goes in the box. Because if you set x plus 4 equal to 0 and solve that, you get negative 4. So that's your 0. So first you put the 0 in the box. Then you pull down your coefficients, drop, drop, drop. So I've got a 1. Then I have a 2. Then I have a negative 11. And then I have a negative 12. And nothing was missing. X cubed, x squared, x constant. So I didn't need any zeros for placeholders. Okay, so I bring down the first number. So bring the 1 down. And then multiply, add until you're done. So multiply 1 times negative 4, add them up. That makes negative 2. Multiply negative 4 times negative 2, that's 8. Add them up, that's negative 3. Multiply negative 3 times negative 4, that's positive 12. Add them up, you get 0. Now, if my remainder was not a 0 here, then I would know that I screwed up. Because if it's telling you that this is a factor, then that means you're definitely going to get 0 as a remainder. Okay, now let's make sense of how to write our answer. This 1 is in front of an x squared. It's always 1 less of an exponent. The minus 2 is in front of the x. The minus 3 is the constant. Now all I need to do is factor this answer, and I'll have all of my factors. Okay, so this is just a typical quadratic, x squared, x constant. So I'm going to a times c rooftop, and it's a easy one. So a times c, 1 times negative 3, that's negative 3. We want the numbers to add to make negative 2. So what multiplies to make negative 3 and adds to make negative 2? Negative 3 times 1. Okay, because it's the easy one, I can go straight to the parentheses. The minus 3 goes in the back. The plus 1 goes in the back. And to get x squared, we just need x and x. So these are your other remaining factors. So x plus 4 is a factor, and these are the others. So I'm looking for x minus 3 and x plus 1. And it looks like C is our winner. Now, I want to show you another way you could do this. But this only works if the answers all come out pretty. Okay? The answers were fractions or square roots of something, then we couldn't do this. Okay, so I'm going to put this original polynomial in my y equals. So x cubed plus 2x squared minus 11x minus 12. Okay, I know the solutions are where the graph touches the x-axis. So let's see where it looks like it touches the x-axis. This looks like negative 4. This looks like negative 1. And this looks like 3. Okay, to know for certain, you want to be finding zeros in the y column. And sure enough, negative 4 is an answer. Negative 1 is an answer. And 3 is an answer. So wherever you see 0 in the y column, these are your zeros or your solutions or your roots, however you want to say it. So 3, negative 1, and negative 4. Okay, so we got lucky because the 3 answers came out pretty. So our answers were negative 4, negative 1, and 3. Well, if these are your zeros, then the factors have always the opposite sign. So opposite of negative 4 is x plus 4, which is what they said was a factor to begin with. X minus, or a negative 1, if that's your answer, then x plus 1 would be the factor. And if it's a positive 3, the opposite would be x minus 3. And that's exactly what we found. X plus 1 and x minus 3. So if you graph it and it touches the x-axis, in 3 nice locations, which you can verify from the table, just look for zeros in the y column, then once you know your 0, the factor will just always be the opposite sign. Okay? And then you don't have to do synthetic division that way. But that only works if it comes out nice. All right, this next one, I could solve algebraically, but I'm going to solve it with the calculator. It wants to know the number and types of roots to this. Okay, so I'm going to put this equation in. So make sure it always says equals 0 or equals y or equals f of x. If it does, you're ready to type it in. So I've got x cubed plus 121x. Okay. So this is supposed to have 3 answers. I can't see anything. Okay, so maybe the calculator's not going to help me. Now, it's supposed to touch the x-axis at 0 because there's an answer. I can tell it from the table. The reason I can't see is because these numbers are so big. Okay, I'm going to just change my my y scale for a little bit. So let's go negative 300 to positive 300, and I'm going to do a scale of 10 just to try to get a better picture. And it looks like a straight line, but that's just because we're not seeing the whole graph. Okay, well, my point to this is, since we only see it touch the x-axis once, then that means there's only one real 0. Remember, however many times the graph touches the x-axis, that's how many real zeros there are. So it's only touching once, and it's touching at 0, 0, because remember, wherever there's a 0 in the y column, that's where an answer is. So since it's only touching the x-axis once, that means there's only one real 0. But I know there's supposed to be 3 answers. So if only one of them's real, that means the other 2 are imaginary. And that's because we don't see the graph touch the x-axis 3 times. So however many times it touches the x-axis, that's how many real answers there are. So it only touches once, so there's only one real answer. The other 2 would be imaginary. So that is answer choice A. Okay, so just look to see how many times it touches the x-axis. If it touches 3 times, there's 3 reals. If it touches 1 time, there's 1 real, 2 imaginary. Remember, imaginaries always come in pairs, so it couldn't be possible to touch twice and have only 1 imaginary if it's x cubed, because imaginaries always happen in pairs. Okay, this one is looking for all of the zeros, and it wants the rational ones, so that means it doesn't want any imaginary answers. Okay, so I'm going to graph this and see what I can find. All right, so 2x cubed minus 11x squared plus 8x plus 21. Now you just saw me mess with my window, and so I want to fix that so it looks normal again. So to fix it, I go zoom and then number 6. That puts it back on a standard window where it goes from negative 10 to 10 and negative 10 to 10. Okay, so I can see it touch the x-axis 3 times. 1, 2, 3. So there's 3 real zeros. So there's no imaginaries at all because there's only 3 answers total. And since it touches 3 times, all 3 answers are real. That doesn't mean they're all whole numbers, or all integers. But let's see what we can find. This one looks like -1. This looks like maybe a 3, and that looks like a decimal. So let's look from the calculator. Okay, -1 is a 0. So -1's an answer. So it looked like -1, and I'm verifying that it's -1 because there's a 0 in the y column. Okay, 3 is an answer because there is a 0 in the y column. So this looked like a 3, and now I know for certain it is a 3. And the other answer, I don't know what it is. I know that this looks like it's somewhere between 3 and 4. Okay, so let's just use some common sense. One answer is -1, one answer is 3. Okay, that's got the -1 and 3. Okay, this has 1, 2, 3, 4, 5, 6 answers. Well, this graph does not touch 6 times, plus it only has an exponent of 3. So it can only have 3 answers total, can't have 6. Okay, this one has the -1 and 3, but we know that there's another answer because it touches 3 times. It's just not an integer. It's not a good looking number. This one has your -1 and 3, but it also has a 7. But this is not a 7. And if I look in my table where the x is a 7, you can see that is not a 0. So it can't be that guy. And I know it's not this because it needs 3 answers. And so this one must be it. Now, 7 halves, if you don't know what 7 halves is, if you go to your calculator and put 7 divided by 2 in your calculator, you get 3.5. Well, this very well could be 3.5 right here, because it's somewhere between 3 and 4, and 3.5 is definitely between 3 and 4. Okay, now I could have done this problem by finding one of the answers in the calculator, doing synthetic division and all that, and I could have found that 7 halves mathematically, but it's not necessary. Sometimes it's good to know some test-taking strategies too. Okay, next up. All right, we are asked to find the inverse. All right, first step of the inverse is to switch x and y. So anytime you're asked to find an inverse, switch x and y. So first you need to remember f of x is just a fancy way of writing a y. So I'm going to switch this y to an x, and I'm going to switch this x to a y. And now we solve for the new y. Okay, there's nothing smushed with it, multiplied with it to get rid of. There's nothing behind it, added or subtracted. So I'm ready to get rid of the cubed right now. Or the cubed root. So to get rid of a cubed root, we cube. And if you cube that side, you have to cube that side. So x cubed is all that's left on the left side. And then the cubed and cubed root cancel each other out. So all you have is y minus 7. And then to get y by itself, we get rid of subtraction of 7 by adding. And then y is all that's remaining. You can't actually add these, so you just leave it, x cubed plus 7. And where do we see x cubed plus 7? Right here. And instead of writing y equals, they're writing it fancy, the inverse of f of x equals, because that's your notation for inverse. Okay, the next one wants to know if these are inverses. And there's a couple different ways to do this. I'm just going to find the inverse of this guy and see if it's this. Okay, so this f of x is just a y. So this y is going to switch to an x. And this x is going to switch to a y. This problem is practically identical to the last one. Okay, so to get rid of a cubed root, we cube. So I'm going to cube both sides. So I'm going to cube this side, and I'm going to cube this side. So x cubed is all that's remaining on the left side. And on the right side, the cube and cube root cancel, leaving y minus 5. And then to get rid of subtraction of 5, I do the opposite and add. And you can't actually add x cubed plus 5, so it just stays x cubed plus 5. Well, does this side say x cubed plus 5? No. So these are not inverses. This does not match that. So no, these are not inverses. If this would have looked just like this, then the answer would have been a yes. But this does not look like this, so the answer is no. Okay, this next one is a solving problem. So we're going to solve this equation. So it's not inverse, we're not switching x and y. We're just trying to get x by itself. But you kind of do the same thing that you did up above. So there's nothing smushed with it to get rid of or outside the cubed root to add or subtract away. So I'm ready right now to get rid of this cubed root. So to get rid of a cubed root, you cube. And if you cube the left side, you cube the right side. On the left side, the cubed and cubed root cancel, leaving 4x minus 1. And on the right side, we have 3 cubed. And 3 cubed, 3 times 3 times 3. 3 times 3 times 3, did I say that 3 times? Is 27, which you can see. 3 times 3 times 3, 3 cubed. It's 27. And then we just need to solve this for x. So to get rid of subtraction of 1, we add 1. And that's going to make 28. So 4x is 28. And then to undo multiplication, we divide. And if you divide by 4, you get 7. So 7 is what you would type in if you were typing this into the computer. Okay, I'm going to finish these next two, stop the video, and then I will start back up again for number 13. Okay, it says, which of the following is a linear factor of this? Okay, I'm going to type it in the calculator first and see what I can see. And if it's not good, I'll fix it. So 2x cubed minus x squared minus 7x plus 2. Okay, let's see where it touches the x-axis. So it touches 3 times, so there's 3 real zeros, and there's only supposed to be 3 total answers, as is. So that means none of them are imaginary. So since it touches 3 times, then there's 3 real zeros. Now that doesn't mean that they're integers, good-looking numbers. They could be decimals or fractions or square roots. Okay, so this one does not look nice. It looks like it's close to -2, but it doesn't look exactly right. That looks like a decimal 2. Now that one does look like a 2, so let's see. So you can see that -2 was not an answer, but +2 is an answer. Okay, so if +2 is an answer, do you know who the linear factor is? X minus 2. The linear factor will always be the opposite sign. Okay, so I know x minus 2 is a factor. So this says something about 1. This says something about 1, 1, 1. Okay, so now I need to see if these others are factors or not. Okay, so I'm going to have to work it. All right, so since I know that 2 is a 0, then I'm going to put 2 in my box. First, you put the 0 in the box. Pull down the coefficients, drop, drop, drop. So I've got a 2, a -1, a -7, and a 2. Okay. I bring down the first number. So I bring down the 2. Multiply. 2 times 2, 4. Add them up. 3. Multiply. 3 times 2, 6. Add them up. -1. Multiply. -1 times 2, -2. Add them up. 0. Okay, so since I got a remainder of 0, then sure enough, 2 is a 0 to the problem, but I already knew that because of the calculator, and my answer is a factor. So let's write this answer and see if we can factor it out. Okay, so this 2 right here is in front of an x squared, always one less. The 3 is in front of the x, and the -1 is the constant. Okay, I'm going to try to factor this, a times c rooftop. It's not the easy one, so here we go. A times c, 2 times -1 is -2, and I want the numbers to add to make 3. What multiplies to make -2 and adds to make 3? Well, there's nothing. Nothing multiplies to make -2 and adds to make 3. Okay, so what that means is you cannot solve this. I'm going to write nothing. You cannot solve this by factoring. So if you were to solve this, you'd have to solve it with the quadratic formula. And if you solved it with the quadratic formula, you get an answer like x equals something plus minus square root of something all over something. Well, they would not give you factors that look like this. Oh, no, hang on a minute. Oh, look at number 3. So it does say that what we got, 2x squared plus 3x minus 1 is a factor. Yes, yes, that is true. And then because this does not factor, then that means there's no other factors. And they're not actually looking for the solutions, so we don't have to continue on with quadratic formula. It's just looking for the factors. So I know 2 is a factor, I know 2 is a 0 because it touches the x-axis at 2, so that means the factor is x minus 2. And then I know that the answer I got is a factor because I got a remainder of 0. So that means 1 and 3 are the only factors. If this would have factored a times c rooftop, like if I had numbers here, then we would have had other factors. But we don't, so that's it. Okay, last one for this video, and then I'll start fresh. Okay, which is the complete factored form of this guy? So there's 4 terms, 1, 2, 3, 4. So when there's 4 terms, we factor by grouping. And first, I am supposed to look for a GCF to the whole problem. That's what you're supposed to look for every time. And do you notice that there is a GCF to the whole problem? What is it? 2. 2 can go into 2, 10, 2, and 10. Okay, so let's factor that 2 out. All right, 2 times what is 2x cubed? X cubed. 2 times what is negative 10x squared? Negative 5x squared. 2 times what is negative 2x? Negative x. And 2 times what is 10? 5. Okay, so I know that there's a GCF of a 2. All of these have a GCF of a 2, but A doesn't, so I know A is not the answer. Okay, so now I'm going to ignore this GCF. I've got 4 terms, 1, 2, 3, 4, so I'm going to factor by grouping. So grouping together the front 2, what's the GCF to the front 2? X squared. They both have 2 x's. Okay, x squared times what is x cubed? X. X squared times what is negative 5x squared? Negative 5. Remember, whatever you write here, you get a copy over here. Now back it up. What times x makes a negative x? Negative 1. Negative 1 times x is negative x. And negative 1 times negative 5 is positive 5. Okay, so build your 2 sets of parentheses. Copy, copy. Whoever you wrote here and here, copy one more time. Whoever's left over, which is your x squared in the front and your minus 1 in the middle, copies here. And then our GCF drops down. Now, you would think that this is the answer, which is answer choice C, but it's not, because this guy is somebody special. This is a difference of squares right here. We've got 2 terms. We've got an even exponent, the minus to make it a difference, and 1's a perfect square. So this is when you do your 2 sets of parentheses, one with a plus, one with a minus. And what's the square root of x squared? X, because x times x is x squared. And what's the square root of 1? 1, because 1 times 1 is 1. And then drop your x minus 5 and drop your GCF. Now it's completely factored. And this is answer choice D. Is that right? No, it's answer choice B. Okay, that's the completely factored form. Okay, we're going to stop the video right here. Smiley face. I'll come back for question 13.